Wait, what the hell is that?
Oh my god, that's 3i Atlas! It's coming straight for Earth, look how fast it's moving!
That's not debris, that's 3i Atlas spore. It's entering the inner orbit now.
Look there! Oh my god!
Guys!
Look at that! It's coming in fast, straight toward Earth!
We have to call control, now!
They said it would disappear. By now, the object known as 3i Atlas should have slipped behind the sun, out of sight, out of mind. But it didn't. It stayed. And in that refusal, something fundamental changed. Its brightness, its speed, its profound, unnerving silence. And now, on December 15th, 2025, Earth and 3i Atlas are destined to align in a way that hasn't happened in recorded history. Every telescope, from the great orbital observatories to backyard instruments, is watching. Every signal, from the deepest radio frequencies to the highest energy gamma rays, is being monitored. Because on that day, it might just do something no one is ready for. NASA, the European Space Agency, all the official bodies, they call it a harmless interstellar visitor, a curiosity. But what if the truth is that it's waiting? Waiting for something or for the right time? Stay with me, because by the end of this story, you will understand why some believe that moment won't just change astronomy. It could change everything we are. The countdown is real, and it is already ticking down. If this mystery has you on edge the way it has me, if you feel that primal pull of curiosity and dread, then don't just stay in the shadows. Be part of this. Hit that like button, subscribe to this channel, because you do not want to miss what happens next as this unfolds in real time. This is a story that needs witnesses. I want you to be one of them. Drop a comment right now. Tell me where you're tuning in from, what time it is there, and whether you believe we're being told the full truth about these world-changing discoveries. If you want to help this community grow, share this video. You are the reason we can keep chasing stories like this. So, thank you for having our back. Now, let's begin. Part 1. The countdown. Begins picture this. You're standing in your backyard on a clear, crisp night in late October 2025, looking up at the stars. Everything looks normal, peaceful, timeless, but somewhere out there, moving faster than any human-made object has ever traveled, something from beyond our solar system, from the void between stars, is racing toward an appointment we didn't schedule, a meeting we never agreed to. NASA tells you not to worry. The European Space Agency calls it routine. They say December 15th will be just another day. But here's what they're not telling you in their press releases. Here's what's keeping amateur astronomers and a handful of worried professionals up at night, refreshing their telescope feeds, checking their calculations again and again. Something about 3i Atlas refuses to behave normally. To understand why this is so deeply unsettling, you have to understand the history. We've only ever detected 3 interstellar objects passing through our cosmic neighborhood. The first was Oumuamua in 2017, that bizarre cigar-shaped visitor that accelerated in ways gravity alone could not explain. Scientists are still arguing, still publishing papers, still fighting over what it was. The second was Borisov in 2019, which acted more like a normal comet, but still raised its own questions about where it came from and what it carried within its icy heart. Now we have 3i Atlas, the third interstellar visitor, and from the moment it was spotted, it has not been following the script. On July 1st, 2025, the Atlas telescope in Chile caught something unusual in its automated survey images, a faint smudge of light moving against the static background of stars. Within days, as astronomers across the globe calculated its trajectory, a stunning realization dawned. This object wasn't bound to our sun. Its orbit was hyperbolic, a deep, open curve meaning it came from somewhere else, from the true interstellar dark, and it would eventually return there, leaving us behind forever. The numbers told a startling story. This thing was moving at a blistering 60 kilometers per second. Its orbital eccentricity was measured somewhere between 6.14 and 620, far beyond the threshold that separates solar-bound objects from interstellar wanderers. It was coming in fast, and it would leave even faster. NASA and ESA quickly published the basic, reassuring facts. Perihelion, its closest approach to the Sun, would occur around October 30th at approximately 1.36 astronomical units. That's inside Earth's orbit, closer than Mars but still a comfortably safe distance. Then, 3i Atlas would swing back out, passing closest to Earth in mid to late December at roughly 1.8 astronomical units away. That's about 168 million kilometers. Nothing to worry about, they said. Just another visitor passing through. But then the whispers started. In the quiet, dedicated corners of astronomy forums, in encrypted amateur observer groups, in the comment sections of YouTube videos analyzing the comet's path, people began sharing observations that didn't quite match the official predictions. Someone claimed they measured the object's position and found it offset by several arc minutes from where the JPL Horizon system, the gold standard for solar system navigation, said it should be. Another observer posted photometry data showing subtle brightness variations that didn't fit the standard models for comet activity. A third noticed that the tail seemed to be pointing in an unexpected direction, as if the object was being pushed or guided by forces the models hadn't accounted for. Were these observations real? Or were they the product of calibration errors, atmospheric distortion, or simple wishful thinking? That is the question that matters. Because if 3I Atlas really is deviating from its predicted path even slightly, then everything we think we know about its December flyby might be wrong. And if the deviations are systematic, if they're accumulating over time, then the geometry of December 15th might be very, very different from what the official ephemerides are telling us. Let me paint the picture of what December 15th looks like in the cold, hard language of celestial mechanics. By that date, 3I Atlas will have passed perihelion more than 6 weeks earlier. It will be moving away from the Sun, but still relatively close to Earth. More importantly, the alignment will be nearly perfect. If you draw a straight line from the Sun through 3I Atlas, it points almost directly at Earth. We will be downstream of the comet, sitting in whatever wake it leaves behind. If 3I Atlas has developed a tail of ionized particles, if it's been releasing gas and dust heated by its close pass of the Sun, then Earth will be directly in the path of that material. At 1.6 to 1.8 astronomical units away, it's still a considerable distance, but it's also close enough for certain kinds of effects to propagate. Radio waves would reach us in about 13 minutes. Charged particles carried by the solar wind could drift across that gap in days to weeks. Even gravitational influences, though infinitesimally weak, would be technically measurable. So, here's the question nobody in an official capacity wants to ask out loud. What if December 15th isn't nothing? What if this specific alignment triggers something we haven't anticipated? I'm not talking about an impact. 3I Atlas is nowhere near close enough for that. I'm talking about something subtler, something far more insidious. An electromagnetic pulse, a burst of coherent radio waves, a sudden impossible brightening or dimming, a glitch in our satellites that can't be explained, an unexplained aurora blooming at latitudes where auroras don't usually appear, something small enough to be dismissed as coincidence by the authorities, but strange enough to make you, and millions of others, wonder forever. The official story is clear and confident. 3I Atlas poses no threat. The trajectory is well understood. The object is just a comet, albeit one from another star system. December 15th will come and go without incident. But confidence and certainty are not the same thing. And in the quiet spaces between the press releases and the public statements, there is room for doubt. There is room for questions. There is room for the very real possibility that we are about to witness something unprecedented, and we don't even know it yet. Part 2. The object that refuses to follow the rules. The official discovery date is July 1st, 2025. But the story of 3I Atlas actually begins earlier than that, much earlier. When researchers went back through archival data from the TESS space telescope, they found something unexpected. The comet was already active, already producing a visible coma of gas and dust, when it was still out near 6.5 astronomical units from the Sun. That's beyond the orbit of Jupiter. Comets aren't supposed to behave that way. The conventional model says they remain frozen and inert, deep in their cryosleep, until they get close enough to the Sun for solar radiation to start sublimating their ices. But 3I Atlas was already awake, already shedding material when it was still in the cold, dark outer reaches of the solar system. That pre-discovery activity tells us something critically important. This object is different. Either it's made of unusually volatile materials that sublimate at lower temperatures than normal comets, or it has some internal heat source we don't understand, or it's not entirely natural. Those are the options, and each one has staggering implications. Let's talk about the numbers that matter. Hubble Space Telescope observations placed constraints on the size of 3I Atlas. The nucleus, the solid core of the comet, is somewhere between 0.44 kilometers and 5.6 kilometers in diameter. That's a huge range of uncertainty. It could be a relatively small chunk of ice and rock, or it could be something much larger, more substantial. The size matters because it determines how much material the comet can release, how strong its own minuscule gravity is, and how much energy it might contain if something inside is generating its own heat. The Gemini Observatory tracked 3I Atlas through its perihelion and confirmed what Atlas had seen: the hyperbolic trajectory, the extreme velocity. But Gemini also added something new, something deeply puzzling: polarimetric data. When light reflects off the comet's coma, it becomes polarized in a way that depends on the size and composition of the dust particles. And 3I Atlas showed something strange: an extreme negative polarization, the kind of signature that suggests dust grains with unusual optical properties, a composition that doesn't match any known comet from our own solar system. It was, for lack of a better word, alien. Now we get to the part that's causing all the intense speculation: the amateur observations. The citizen scientists with their backyard telescopes and CCD cameras who track objects like 3I Atlas with a passion that often surpasses that of the professionals. Starting in October, some of these dedicated observers began reporting discrepancies. One group claimed they measured the comet's right ascension and declination coordinates and found consistent offsets of several arc minutes compared to the predicted ephemeris. Another reported brightness curves that didn't match the expected steady decline as the comet moved away from the sun. A third noticed variations in the tail structure that seemed to suggest non-gravitational accelerations, tiny pushes and shoves that weren't from the sun's gravity. Here's where it gets tricky. Amateur observations are incredibly valuable, but they're also prone to error. Atmospheric refraction can bend light and shift apparent positions. Calibration mistakes can throw off photometry. Telescope tracking errors can create false motion. So when someone reports an arc-minute offset, we have to ask, is that real or is it noise? The official ephemeris from JPL Horizons includes uncertainty intervals. Small deviations are expected and normal. But what if the deviations aren't small? What if they're systematic and growing? Let's do the math. An arc-minute is 1/60th of a degree. At a distance of 1.8 astronomical units, one arc-minute of angular offset corresponds to a lateral displacement of about 780 kilometers. That is not trivial. If 3I Atlas is really 780 kilometers off course from where it should be, that represents a significant unmodeled acceleration. Over the course of weeks, a tiny constant acceleration could accumulate into exactly that kind of displacement. What could cause such an acceleration? The most likely answer is asymmetric outgassing. When ice sublimates on one side of the comet's nucleus, it creates a jet that pushes the nucleus in the opposite direction, like a leaky, uneven rocket. This is a known phenomenon. We've observed it in dozens of comets, but the magnitude matters. For 3I Atlas to deviate by hundreds of kilometers, the outgassing would have to be unusually strong or unusually one-sided. And if that's the case, then the comet is more active, more volatile, more unpredictable than the models assumed. Or there's another possibility. What if the deviations aren't caused by outgassing at all? What if there's something else at work? A plasma interaction with the solar wind? A gravitational perturbation from an unseen companion mass? Or something else entirely? A propulsion system? Yes, I said it. The idea sounds absurd, but Oumuamua taught us that absurd ideas sometimes deserve serious consideration. When an object doesn't behave the way physics says it should, you have two choices. Either your physics is incomplete, or the object is not what you think it is. NASA's official position remains unchanged. 3I Atlas is a comet. Its trajectory is understood. The approach to Earth in December poses no risk. But here's what they're not saying. They're not releasing daily public updates on the object's precise position. They're not publishing detailed raw photometry data. They're not addressing, point by point, the amateur observations that claim to see these anomalies. That silence could mean nothing. It could mean they're busy with other priorities. Or it could mean they're waiting, watching to see if the anomalies resolve themselves or become more pronounced before making any public statements that could cause alarm. December 15th is coming. Whether we're ready or not, the geometry is set. Earth will be in perfect alignment with the Sun and 3I Atlas. We'll be downstream of its tail, in the direct line of sight of whatever it has been releasing since its perihelion. If the amateur observations are correct, if the deviations are real, then the object might be closer than expected or oriented differently than predicted. And if that's the case, then the alignment might be tighter, more precise, more significant than anyone in authority is acknowledging. The question isn't whether something will happen. The question is whether we'll be paying enough attention to notice when it does. Part 3. The geometry of convergence. Imagine a clock, a vast cosmic clock. The sun is at the center, and the planets orbit like the hands, sweeping around the dial in their stately, predictable dances. Now imagine a visitor from outside the clock entirely, a piece of interstellar debris that doesn't care about our orderly clockwork, that cuts across the face at a sharp, unexpected angle, moving faster than anything bound to the sun's gravity could ever move. That is 3I Atlas. And on December 15th, 2025, the hands of our cosmic clock will point in just the right direction for something unusual, something unprecedented to happen. Let me be precise about this geometry. Perihelion occurred around October 30th, when 3I Atlas made its closest approach to the Sun at approximately 1.36 astronomical units. That's about 204 million kilometers. Close enough for solar radiation to heat the nucleus intensely, vaporizing ices, releasing trapped gases, creating the glowing coma and the magnificent tail that make comets so visible, so haunting. For several weeks after perihelion, the comet has been moving outward, climbing back up the Sun's gravity well, heading toward its eventual escape from our solar system forever. By December 15th, 3I Atlas will be at roughly 1.6 to 1.8 astronomical units from both the Sun and the Earth, but distance isn't the only thing that matters. What matters, what truly sends a shiver down the spine, is the alignment. On that date, if you draw a straight line from the Sun through the comet, it points almost directly at Earth. We're not just nearby. We are downstream. We are in the zone where the comet's tail should be, where its exhaust, for lack of a better term, is pointing. Comet tails come in two primary types. Dust tails are made of microscopic particles pushed outward by the gentle but constant pressure of solar radiation. They curve gently, following the comet's orbital path like a smoky trail. Ion tails, however, are different. They are made of charged particles, ionized by the Sun's intense ultraviolet light, and they are pushed directly away from the Sun by the solar wind, a stream of charged particles constantly flowing from the Sun. They point straight out, like a flag blowing in a stiff breeze. If 3I Atlas has an active ion tail, and all evidence suggests it does, and if that tail is oriented correctly, then on December 15th, Earth will pass through it. Now, 1.6 astronomical units might sound like a lot of space. It is. That's about 240 million kilometers. But consider what can propagate across that distance. Radio waves travel at the speed of light, covering the gap in about 13 minutes. Charged particles in the solar wind move at several hundred kilometers per second, taking days to weeks to drift from the comet to Earth. Even relatively slow-moving dust particles, if they're small enough and charged enough, can be carried along by electromagnetic forces. The question is not whether anything from 3I Atlas can reach us. The question is what reaches us and what effect it has when it arrives. Let's talk about coupling. That's the physics term for how two systems interact and exchange energy. Earth has a magnetosphere, a protective bubble of magnetic field that shields us from most of the charged particle radiation streaming from the Sun. When that solar radiation hits the magnetosphere, it can cause disturbances. Magnetic field lines stretch, snap, and reconnect. Electric currents flow in the upper atmosphere. We see the beautiful result as auroras. We also experience the potentially damaging effects as geomagnetic storms that can disrupt satellites, GPS, and even power grids on the ground. Now, imagine that instead of the usual solar wind, Earth's magnetosphere encounters a stream of ionized particles from a comet's tail, a stream from an object that is not of this solar system. Would it behave differently? Would the coupling be stronger or weaker? Would we see effects that don't fit the normal patterns? The distances involved are significant. At 1.6 astronomical units, the density of the solar wind is much lower than it is near Earth. The magnetic field carried by the solar wind is also weaker, but a comet's ion tail can contain its own self-generated magnetic structures, twisted loops and filaments created by the complex interaction between the outflowing cometary gas and the interplanetary magnetic field. If Earth's magnetosphere encounters one of those structures, even briefly, it could trigger localized disturbances. Unexplained auroras at unusual latitudes, brief radio blackouts, unexplained satellite telemetry glitches. Nothing catastrophic. Nothing that would make screaming headlines under normal circumstances. But enough to be noticed. Enough to raise very serious questions. There's another more profound possibility. What if the alignment isn't just about geometry? What if it's about timing? Suppose that something about 3I Atlas's passage through perihelion triggered a latent event, a release of stored energy, a burst of activity, a fundamental change in the object's behavior. And suppose that event produced something, a signal, a particle beam, a wave that propagates outward at a specific, calculable speed, timed to arrive at Earth's location precisely on December 15th. That's pure speculation. I'll admit it freely. But it's speculation grounded in physics. If an object releases electromagnetic radiation, it travels at light speed. If it ejects particles, they travel at whatever velocity they were given. If it creates a disturbance in the interplanetary medium, that disturbance propagates as a wave. The timing could be coincidental, a random act of cosmic chance, or it could be deliberate. This is where the mainstream scientists shake their heads and walk away. They'll tell you there's no known mechanism for a comet to produce a targeted timed effect. They'll tell you that any release of energy would be isotropic, spreading out in all directions like the light from a bulb, not focused on Earth like a laser. They'll tell you that the alignment is meaningless, a purely geometric coincidence that we humans, with our pattern-seeking brains, are imbuing with significance. And they're probably right. Probably. But here's what keeps me up at night. We have never, in the entire history of modern astronomy, had an interstellar comet with an active coma and tail pass through our solar system in such a geometrically perfect alignment with Earth. Oumuamua was the first, but it didn't have a visible tail. Borisov was the second, but its geometry was different, less precise. 3I Atlas is giving us a scenario we have never tested, never witnessed, never even imagined in our models. An interstellar visitor with an active coma and tail, passing close enough to potentially interact with Earth's magnetosphere, aligned in a way that puts us directly in its outflow path. We have models and predictions, sure, but models are only as good as the data they're built on. And we have exactly zero data for this specific situation. December 15th is a test. Not a test we designed, not a test we wanted, but a test nonetheless. If nothing happens, the models are validated and the skeptics can say they told us so. If something happens, even something small and seemingly insignificant, then we learn, irrevocably, that our understanding of cometary interactions, of interstellar objects, was incomplete. Either way, we learn. But I can't help wondering which outcome would be more unsettling. The confirmation that we understand everything, or the revelation that we've been missing something profound all along. Part 4. 5 scenarios. Nobody wants to consider. I'm going to walk you through 5 hypotheses, 5 scenarios that could, in theory, produce observable, physical effects on or around December 15th. I want to be crystal clear from the start. None of these are mainstream scientific predictions. These are thought experiments. They're the kinds of ideas that get discussed in hushed tones after conference sessions, or kicked around in late-night forum threads by people who enjoy pushing the boundaries of the possible. But they are worth examining, because even the most speculative hypothesis can teach us something about what is possible and what is not, and they force us to confront the limits of our own knowledge. Scenario 1. The silent activation event. Here's the premise. 3I Atlas has been traveling through the unimaginable cold and emptiness of interstellar space for millions, perhaps billions of years, completely cold and dormant. Then it enters our solar system, approaches the sun, and heats up for the first time in its long, lonely history. That heating doesn't just sublimate surface ices, it triggers something deeper. Maybe it's a chemical reaction deep inside the nucleus, a chain reaction waiting for a catalyst. Maybe it's the sublimation of a hypervolatile compound that was stable in the near absolute zero of interstellar space, but becomes unstable in sunlight. Or maybe it's something more exotic, a stored energy source, a battery, for lack of a better word, that we don't have a name for yet. Whatever it is, it activates at or near perihelion. And this activation produces an output, a burst of electromagnetic radiation across a specific band, a focused release of particles. Something that propagates outward not in all directions, but in a directed beam or a carefully calculated spreading wave. If the timing and orientation are just right, that output reaches Earth on December 15th. What would we see? It depends on the nature of the output. If it's radio waves, we might detect a powerful, transient signal, possibly at frequencies we don't normally monitor. If it's high-energy particles, we'd see a sharp, localized uptick in cosmic ray detectors and satellite radiation monitors. If it's a coordinated electromagnetic pulse, we might see temporary, simultaneous disruptions in communications or power systems in a specific part of the globe. None of these would be globally catastrophic, but they'd be noticeable, they'd be synchronized, and they'd be utterly unexplained by any conventional cometary model. Scenario 2. Gravitational and plasma resonance. This one is subtler, and in some ways, more plausible. The idea is that the specific alignment on December 15th creates a unique configuration where Earth's magnetosphere becomes unusually sensitive, almost like a tuning fork, to disturbances in the interplanetary medium. Its resonance hit the right frequency, and a small input can create a large amplified output. Normally, Earth's magnetosphere is robust and well shielded, but under certain very specific conditions, when the solar wind has just the right velocity, density, and magnetic orientation, even a small perturbation can trigger a disproportionately large response. Now suppose that 3I Atlas's ion tail carries its own unique magnetic structures shaped by its alien composition. And suppose those structures, as they wash over Earth, interact with our magnetic field in a way that hits that exact resonance point. The result would be an enhanced and perhaps unexpected geomagnetic response. Auroras would appear at latitudes where they are never seen, over the tropics, for instance. Ground-based magnetometers would register anomalous, sharp fluctuations. Satellites in certain orbits might experience increased drag or electronic interference. Again, nothing apocalyptic, but enough to show up clearly in the data. Enough to make space weather forecasters and physicists wonder, with genuine confusion, what the hell just happened. Scenario 3. Fragmentation and outgassing. Burst comets are fragile things. They are not solid, cohesive rocks. They are often described as dirty snowballs or icy dirt balls, piles of ice, dust, and rock held together by the faintest whisper of gravity and even weaker chemical cohesion. Sometimes they break apart, especially after a close pass of the sun when extreme thermal stresses crack the nucleus apart. If 3I Atlas underwent a partial fragmentation around perihelion, the pieces would continue on slightly different trajectories. Some of those fragments, with fresh, newly exposed surfaces, might outgas more vigorously than the main nucleus, releasing sudden, powerful bursts of gas and dust that create temporary, dense clouds within the larger coma. If one of those bursts happens to occur just as the geometry aligns on December 15th, Earth might find itself passing through a denser than expected cloud of cometary debris. The effects would be short-lived but measurable. Satellites in low Earth orbit would experience a sudden, unexpected increase in atmospheric drag. There might be a noticeable uptick in meteor observations as these alien dust grains burn up in our upper atmosphere. Optical telescopes might detect a sudden, brief brightening of the comet, or a dramatic change in its tail structure. It wouldn't last long, maybe hours, perhaps a day or two. But for that brief window, 3I Atlas would be behaving in ways the models didn't predict, providing a spectacular and unnerving display. Scenario 4. The probe hypothesis. Now we are venturing into territory that most astronomers refuse to acknowledge in public. But since we are here, let's go all the way. Suppose 3I Atlas is not entirely natural. Suppose that embedded within its icy nucleus, hidden from our telescopes and spectrometers, is something artificial. A probe, a relay, a dormant machine that has been coasting through the galactic void for eons, waiting for the right conditions to activate. It doesn't have to be large. A device the size of a car, buried deep inside a comet nucleus several kilometers across, would be utterly invisible to our best instruments. And it doesn't have to be active all the time. Maybe it wakes up only when it detects the specific radiation signature of a G-type star like our Sun. Maybe it uses the solar radiation during perihelion to recharge its ancient power systems. Or maybe it waits, patient and silent, until it's in a specific geometric configuration, like the perfect alignment with a life-bearing planet on December 15th. And then it transmits a signal, a beacon, a packet of information sent toward a particular point in space, or perhaps broadcast in all directions. If Earth happens to lie along that transmission path, we would receive that signal. It might be at a common radio frequency, or it might be optical, a laser-like pulse, or something else entirely that we haven't even thought to look for. It might be modulated in a way that stands out clearly from the background noise of the universe. A sequence of prime numbers, the digits of pi, a simple bitmap image. Or it might be so subtle and complex that only dedicated long-term monitoring would ever catch it. SETI researchers dream of scenarios like this, a techno-signature delivered to our cosmic doorstep by a wandering interstellar probe. It is the ultimate long shot, the ultimate leap of faith, but it is not physically impossible. Scenario 5. The optical reflection phenomenon. This one is almost mundane compared to the others, but it is deeply unsettling in its own way. Suppose that on December 15th, the angle between the Sun, 3i Atlas, and Earth reaches a specific critical value that maximizes the reflection of sunlight off the comet's coma. Think of it like a glint, the way sunlight reflects off an airplane's fuselage or a distant mirror at just the right angle, and you see a brilliant momentary flash. If the dust particles in 3i Atlas's coma have the right size, composition, and are arranged in a particular configuration, perhaps aligned by magnetic fields, the comet might suddenly, without warning, brighten by several magnitudes for a few hours. It could become, for a brief time, one of the brightest objects in the night sky. Observers across the globe would see a temporary, startling increase in brightness. Social media would instantly light up with reports of a strange new star or a mysterious glow. Amateur astronomers would scramble to capture images. And then, just as suddenly it would fade, returning to its normal brightness as the geometry changed. Nothing dangerous, nothing harmful, but eerie, psychologically unsettling, the kind of thing that makes people feel, deep in their bones, that the universe is winking at them, sending a message, even when it's just the cold, impersonal laws of physics playing tricks with light. These 5 scenarios span a vast range, from the edges of conventional physics to the wildest shores of speculation. What they all have in common is that they are all, strictly speaking, technically possible. The probabilities vary enormously. Some are vanishingly unlikely, others are merely improbable, but none of them violate the known laws of nature. And that is what makes December 15th so profoundly interesting. It's not that we expect any of these scenarios to occur. It's that we cannot, with absolute certainty, completely rule them out. And in that gap between expectation and certainty, in that sliver of cosmic uncertainty, there is room for surprise. There is room for wonder. And there is room for fear. Part 5. The Architecture of Institutional Silence. NASA's official statement on 3i Atlas is a masterpiece of brevity and confidence. The object poses no threat to Earth. Its trajectory is well understood. The December approach is a routine event that will be monitored by standard observational protocols. Nothing to see here. Move along, and maybe they are right. Maybe there really is nothing to see. But there is a curious, and to many, a concerning pattern in how information about 3i Atlas has been managed since its discovery, and that pattern deserves our close attention. Let's start with a comparison. When Oumuamua was discovered in 2017, it took weeks for the scientific community to realize it was interstellar. Initial observations suggested a normal asteroid. Only after detailed orbit calculations did astronomers understand they were looking at something from beyond our solar system. The announcement, when it finally came, generated an enormous public and media frenzy. News articles, documentary segments, congressional inquiries. Everyone wanted to know what Oumuamua was and where it came from. With 3i Atlas, the process has been strikingly different. The interstellar nature of the object was recognized almost immediately, within days of its discovery. The initial announcement mentioned the hyperbolic orbit, but after that, the flow of information from the major space agencies slowed to a trickle. There have been no major press briefings. No detailed, preliminary scientific papers rushed into high-profile journals like Nature or Science. No daily press releases with new images or data from Hubble or JWST. The object is being tracked, certainly. Data is being collected without a doubt, but it is not being shared with the same level of public transparency and engagement that accompanied Oumuamua. Why the difference? One possibility is that 3i Atlas is simply less interesting from a purely scientific standpoint. It appears to be a comet, and we have studied hundreds of comets. An interstellar comet is novel, but perhaps not novel enough to warrant the same media circus. But that explanation doesn't quite fit. The pre-discovery activity at large heliocentric distances is highly unusual. The extreme negative polarization is unusual. The persistent amateur reports of trajectory and brightness anomalies are unusual. By any objective measure, there is plenty of interesting, potentially groundbreaking science here. So why the quiet? Another possibility is institutional caution. The space agencies learned from the Oumuamua experience that announcing surprising, Half-understood results too early can lead to a media frenzy that quickly spirals out of control into speculation about alien probes and government cover-ups. NASA might be deliberately downplaying 3I Atlas to avoid a repeat of that circus. Better to wait, the thinking might go. Until the data is complete, the analysis is thorough, and the interpretation is certain before making any public statements that could be misunderstood or sensationalized. But there is a third possibility, one that is harder to dismiss and one that fuels the online speculation. What if the silence isn't about caution or a lack of interest? What if it's about genuine, profound uncertainty? What if NASA and ESA are seeing something in their data, their high-precision, calibrated professional data, that they genuinely do not understand and do not want to discuss publicly until they have a better, more stable explanation? Institutional science is inherently risk-averse. Announcing an anomaly before you can explain it is a career-damaging move. It can lead to ridicule, loss of funding, and a loss of credibility. Far safer, far more prudent to stay quiet, to run more observations, to double-check and triple-check the calculations, to consult behind closed doors, and only to go public once you have a complete, coherent, and defensible story. Now let's talk about protocols. The International Academy of Astronautics has a set of guidelines called the Post-Detection Communication Protocols for dealing with potential techno-signatures. These protocols outline the steps that should be taken if a signal of possible extraterrestrial origin is detected. The key points are verification, consultation with other experts, and eventual public disclosure. But there is a built-in delay. The protocols emphasize that no public announcement should be made until the detection is confirmed and the implications are at least partially understood. Has 3I Atlas triggered any of these protocols? We don't know. The protocols were designed primarily for radio signals and deliberate transmissions, not for the ambiguous physical behavior of a comet-like object. But some observers have speculated that the unusual characteristics of 3I Atlas might have prompted informal, confidential consultations among SETI researchers and planetary defense experts. If there is even a remote, non-zero possibility that the object is artificial or is carrying some kind of signal, you can be certain that those conversations are happening. But they are happening behind closed doors, in secure rooms, far from the public eye. The Planetary Defense Coordination Office, part of NASA, maintains internal watch lists of objects that warrant additional monitoring. This includes near-Earth asteroids with uncertain trajectories or unusual properties. 3I Atlas is not a near-Earth object in the technical sense, but some forum posts from alleged insiders have claimed that it was briefly listed on these internal watch lists, used for training exercises or protocol development. Those claims are unverified and unverifiable. NASA has not confirmed or denied them, but if true, it would suggest that someone, somewhere in the chain of command, thought that 3I Atlas deserved a higher level of attention than the public statements would imply. Here's where human psychology comes in. We are pattern-seeking creatures. We see connections and meanings even when none exist. When a powerful institution stays silent, we instinctively fill that void with our own speculation. The absence of information becomes, in our minds, evidence of concealment. This is how conspiracy theories are born, not necessarily from malice, but from the natural human response to the gap between what we want to know and what we are being told. December 15th has become a focal point in online discussions precisely because it is a date, a specific concrete moment in time. If you are going to believe that something unusual is happening with 3I Atlas, you need a when. December 15th provides that when. It's close enough to feel imminent. It's specific enough to allow for predictions and preparations. And it's aligned with enough celestial geometry to sound scientifically plausible. Whether anything actually happens on that date is almost beside the point. The date itself has acquired a life of its own, a meaning, simply by being repeated enough times in enough contexts. I'm not here to tell you whether NASA is concealing something. I don't know. I cannot know. But I can tell you that the structure of institutional silence creates the perfect conditions for doubt to thrive. Every unanswered question becomes a seed of suspicion. Every delayed release of data becomes potential evidence of a cover-up. And every public assurance that there's nothing to worry about, paradoxically, strengthens the belief in some that there is. In fact, something very real to worry about. This dynamic is playing out right now. In real time, as December 15th approaches, the silence from the official channels is not breaking. The pointed questions from the public are not being answered. And the countdown continues, its ticks growing louder in the quiet. Part 6. Lessons from the visitors that came before. To fully understand the significance of 3I Atlas, we must look back at the visitors that paved its way. They are our only context, our only guide to understanding what might be coming. In October 2017, a University of Hawaii telescope scanning the skies for near-Earth asteroids caught something that should not have been possible. An object moving so fast, on such a steep, open trajectory, that it could not be bound to our sun. The discovery team named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. That name would prove to be more prophetic than anyone could have imagined. Oumuamua was unlike anything we had ever seen. Its shape, inferred from its dramatic light curve, was highly elongated, perhaps 10 times longer than it was wide. A cosmic cigar. It showed no visible sign of a coma or tail, so it wasn't a comet in the traditional sense. But as telescopes tracked it over the following weeks, they noticed something deeply strange. The object was accelerating. Not much, just a tiny, persistent extra push beyond what solar gravity alone would predict. That non-gravitational acceleration became the central mystery of Oumuamua. Scientists proposed various explanations. Maybe it was outgassing after all, but so faintly and with such pure gases that we couldn't detect the coma. Maybe it was being pushed by radiation pressure, the physical force of sunlight bouncing off its surface. But none of the explanations fit the data perfectly. The acceleration seemed too strong for radiation pressure, unless the object was incredibly thin and light, like a solar sail. The absence of a visible coma made the outgassing hypothesis uncomfortable, and so the debates began, and they rage to this day. Some respected researchers, including Harvard astronomer Avi Loeb, suggested that Oumuamua might be artificial, a light sail, a discarded piece of alien technology, something built rather than born. The scientific community largely rejected that idea. Extraordinary claims require extraordinary evidence, and the evidence for an artificial Oumuamua was circumstantial at best. But the controversy taught us a crucial lesson. When an object behaves in ways we don't expect, we must be willing to consider unconventional explanations, not as a first resort, but as possibilities that remain on the table when all conventional explanations fail to satisfy. 2 years later, in August 2019, amateur astronomer Gennady Borisov discovered a second interstellar visitor using a telescope he had built himself. This one was clearly, unequivocally a comet. It had a bright clear coma and a distinct tail. Its composition, analyzed through spectroscopy, seemed broadly similar to comets from our own solar system. Borisov was, in many ways, exactly what we had expected an interstellar comet to look like, and that was reassuring. It suggested that Oumuamua might have been an outlier, an unusual oddity, rather than a sign that we fundamentally misunderstood the nature of interstellar objects. But even Borisov had its surprises. Its carbon monoxide to water ratio was different from that of typical solar system comets, a hint of its foreign origins. Its nucleus fragmented as it approached the sun, breaking into multiple pieces that dispersed along its trajectory. And like Oumuamua, it exhibited non-gravitational acceleration due to outgassing, though in Borisov's case, the mechanism was clear and uncontroversial. Now we have 3I Atlas, the third interstellar visitor. What does it teach us already? First, that these objects are incredibly diverse. Oumuamua had no visible coma. Borisov had a strong, active coma. 3I Atlas shows extreme polarization and unusual dust properties. Each one is different, a unique individual, and each one challenges our assumptions in its own way. Second, non-gravitational accelerations appear to be common. Both Oumuamua and Borisov exhibited them. If the amateur observers are correct that 3I Atlas is also deviating from its predicted path, that would make it 3 for 3. This isn't an anomaly. It might be the norm for interstellar objects. And third, our detection and characterization capabilities are improving dramatically. We found Oumuamua only after it had already passed perihelion and was on its way out. We found Borisov several months before perihelion, giving us more time. We found 3I Atlas even earlier, with pre-discovery detections extending back to when it was still far from the sun. This progression matters. Each interstellar object we detect teaches us more about what's out there in the galactic void, but it also reveals, with stark clarity, how much we still don't know. Before 2017, we had theories about interstellar objects, but no direct observations. Now we have 3 data points, and each one has raised as many questions as it has answered. How common are objects like Oumuamua? Where do they truly come from? How long do they spend in the darkness between stars? Are there objects out there that are even more exotic, more inexplicable than what we've seen so far? The history of these three visitors also reveals a pattern in how we, as a species, respond. With Oumuamua, there was initial excitement, followed by intense scrutiny, and then lasting bitter controversy. With Borisov, there was interest, but less public drama, because it fit our expectations better. With 3I Atlas, we are still in the early formative phase. The data is incomplete. The interpretations are preliminary. But the seeds of the next great controversy are already being planted, watered by those persistent amateur observations and the whispers of trajectory anomalies. If December 15th passes without any incident, 3I Atlas will probably fade from public view, joining Borisov in the category of interesting, but not shocking. If something unexpected happens, even something small and subtle, it could become the next Oumuamua, a source of debate, speculation, and wonder that persists for years, even decades. There's a profound lesson in all of this about humility. Each of these objects has reminded us that the universe is under no obligation to conform to our models, our expectations, or our desires. We build our theories based on the data we have, but the data we have is always incomplete. These interstellar objects spend millions, perhaps billions, of years crossing the unimaginable void between stars. They experience environments and conditions that we can barely simulate in our most advanced laboratories. When they finally arrive in our tiny, provincial solar system, they bring with them information about processes and compositions that might be rare or entirely absent in the objects born here. They are messengers, whether they are simple rocks of ice or something more. The real question isn't whether 3I Atlas will surprise us. The question is whether we are ready to be surprised, whether we have the instruments, the funding, the attention span, and most importantly, the intellectual flexibility to recognize something truly novel when it appears right in front of us. Oumuamua slipped away before we could get a really good look at it. Borisov gave us more time, but still left unanswered questions. 3I Atlas is still here. It is still observable. It is still approaching its moment of closest alignment. We have an opportunity, a second chance, a third data point. Whether we use this opportunity wisely remains to be seen. The clock is ticking. December 15th is coming.